Welcome back, folks. Now that you guys understood the most fundamental relationship inside an electronic circuit, this fundamental relationship, by the way, is called Ohm's law, which you may have figured out by now. Ohm's law, OHMS law, basically is a very, very important relationship between V and I and R, the current, the voltage, and the resistance inside your circuit. This very fundamental equation really defines how most electronic circuits or all electronic circuits function. So if you look at this once again, let's verify this law. Now in this circuit, the first one that we made during this course, we took a battery and connected it to an LED. And the only resistance in this circuit was actually the wires itself that have a little minute amount of resistance and the breadboard. So you have a very, very small number for resistance. If this number is small and this number is equal to a constant, which is 3 volts, then what happens to this number? It becomes very, very big. And hence, you can see that in the LED. The light is bright and it's getting a lot of current. If you look at this one over here, there is a bunch of resistors in the middle of the battery and the voltage supply, which is the battery. So when this happens, logically, it's going to be dimmer, right? But let's verify that with Ohm's law. Over here, what's happening is that your R is very, very high. It's a big number. And your voltage is again a constant, which is the same as this one. So it's 3 volts. What's going to happen to I? It has to be a smaller number compared to this circuit, which is exactly what Ohm's law suggests, which is exactly what we're talking about in this course. So going forward, this will help you understand, if you just pay attention to the simple relationship, the fact that voltage, current, and resistance, they have an inversely proportional relationship. So if your resistance goes high, your current goes low. If your current goes high, your resistance goes low, and vice versa. And your voltage remains constant throughout this circuit. Now, you can play around with this and try out a few more circuits to understand this a little bit better.